Good morning guys, welcome to Builders Online Academic Tutorial. Thanks for watching our YouTube online. Please, if you have not yet subscribed to this YouTube channel, do well to press the subscribe button and the notification bell in order to see all of our educative videos online. And we want to encourage you to please share this video, like it, and make sure that you invite your friends to watch these videos as well. Thank you and God bless you. Today we'll be considering chemistry in preparation towards Jamb 2022, and today we'll be considering the topic electrolysis. Electrolysis is the chemical transformation through passage of electricity through in a reaction. Now what do I mean by that is that when you use the action of electricity to produce some chemical reaction is what we call electrolysis. Now, electrolysis occurs when you use an electrolyte, when you dissolve an electrolyte in a particular solvent and they dissociate into the ionic part, such as sodium chloride. But we have something we call electrolyte. Electrolyte is a substance which, when dissolved in water or when in its molten state, produce electricity. That is, it conducts electricity. So when I ask what is electrolyte is any substance which, when dissolved or in the molten state, conducts electricity. An example of electrolyte is what we call sodium chloride. Sodium chloride, we have sodium chloride is a popular word. And some people call it brand sodium chloride. Sodium chloride, we have when it dissociates in its molten state, it becomes N plus chloride minus. Another example is sulfate salt. Sulfate salt, when it dissociates, it forms 2 Cu2 plus SO4 2 minus. These are called electrolytes. Electrolyte. They are different from conductor. Conductor conduct electricity in their solid states. Examples are Examples are iron. Iron in its solid state conduct electricity. So, but these ones conduct electricity in their molten state or in solution. So that's electrolytes. That's one of the things we need to consider. We have something we call electrodes. Electrodes are we call it poles. They are electric poles. Electric poles which can be anode or cathode, which can be anode or cathode. It can be anode or cathode. And this helps we use this word also in electrolysis. One of the terms in electrolysis, where anode is a pole, an electrode, where oxidation takes place. Oxidation takes place at the anode. Oxidation takes place. Please know that oxidation takes place at the anode, while reduction takes place at the cathode. Reduction takes place at the at the cathode. So now, when you say oxidation takes place at anode, it means that anode is a reducing agent. It's a reducing, because wherever oxidation takes place, the substance that causes oxidation to occur is what we call reducing agent. But let's leave it like that. Know that oxidation occurs at anode and reduction occurs at cathode. Meaning that which of these reactions will undergo reduction, which of these species undergo reductions, and which of these species undergo oxidation during electrolysis of brine. Now, for example, if I want to write reaction under anode here, the reaction that will be under anode here will be oxidation, like chlorine now, iron. Now losing electron. When you lose electron minus E minus, it becomes chlorine gas. Let me just put. So if I want to write in the 2 form now, 2 chlorine minus 2 chlorine. So 2 chlorine minus 2 electron will give me chlorine gas. And this is an oxidation reaction. So an oxidation reaction that we also have here is SO4 2 minus. So this one can occur like this, on minus 2 electrons from it, or minus 2 electron. You can have SO3 plus what? O2. So that's that. These are the reaction that occurs when you what? In anode, when you use sodium chloride as your electrolyte. So this reaction will take place in the anode. When you use what? Copper sulfate now, this reaction will take place at what? At the anode. Now cathode. What takes place at the cathode is reduction. You can say oxidation takes place here. And reduction takes place here. Now, how do you know that is a reduction and oxidation reaction? Because this has loose electron, and when there is electron loss, we have oxidation. So that's why I know that that's an oxidation. Don't worry, I'm going to do a video on oxidation and reduction as well. So now, when you are talking about what? Now, reduction that takes place using what? Using sodium chloride now. We have sodium plus, that is sodium plus 1. We accept electron. We accept one electron to form sodium solid. You have sodium aqueous. Now, this is sodium aqueous plus. Now, it has accepted electron to form what? To form what? Solid. So this plus 1 to 0. Plus 1 to 0, that is reduction. It's going from plus 1 to 0, that is reduction. And the last one here, which is what? Copper 2 plus. Copper 2 plus accepted what? 2 electrons to form what? Copper solid as well. So when you collect water solid as well, it becomes 0. So that's why we said oxidation takes place at the anode and reduction takes place at what? At the cathode. So now, we have anode, you have the electrode, which is anode and cathode. We have that and that. So these are the major what? Then just is a sketch of an electrolysis taking place. We have things suspended here. Negative, positive, something like that. And this is an electrolyte here. An electrolyte can be Cu plus SO4 towards minus, going towards the positive, and this one's going towards what? Negative. So electric current, I or whatever they use. So before we go into calculation of electrolysis, there are two laws that you need to know. Law of what? Laws of electrolysis, which is known as Faraday laws of electrolysis. Faraday's laws of electrolysis. There are two laws that you need to know, postulated by Faraday. Faraday laws of electrolysis. Faraday law of electrolysis. Faraday law of electrolysis. Now, what do you mean by Faraday laws of electrolysis? Now, the first Faraday law of electrolysis says that Faraday law of the first Faraday law of electrolysis, it states that the mass of a substance produced by what? The mass of substance produced is directly proportional to the quantity of what? Electricity passing through that substance during electrolysis. Now, I come again. Now, the Faraday first law of electrolysis says that the quantity of mass of a substance produced in an electrolysis reaction, is equal to the quantity of electric current passed through that substance. Now, mathematically, it means that first of all, mathematically is given as what? Mass of the substance is directly proportional to the quantity of what? Of electricity passed through that substance, Q. So meaning that now this M is directly proportional to Q. So meaning that M is equal to what? M is equal to what? M is directly proportional to what? Q itself is quantity of what? Charge, which is given as what? Current, that is I times T. So M is directly proportional to what? IT. So we have M. We have therefore we have M equal to what? You introduce a constant which is called electrochemical equivalent. EIT, electrochemical equivalent. So E is given as what? E is known as what? Electrochemical equivalent. Electrochemical equivalent. So that is the first law of what? Electrolysis. That is the first law of what? Electrolysis. That is the first law of what? Electrolysis. Now the second law of electrolysis says that the what? The same amount of milk, we are having what? More than two substances being used, and their masses, they are having the same what? The same substance being used in an electrolysis, and the same current passes through them. Then we say that the mass will be equal to the what? To the chemical what? Equivalent. That is the second law of electrolysis saying that second law of what? Of electrolysis. It says that what? If you have different masses, for example, mass M1 and mass what? M2 of what? If you have mass M1 and mass M2 of a substance that is being used during electricity, that has been dissolved in water for what? As an electrolyte, is what? And the same quantity of current is passed through it to them. Then we say that their mass will be equal to their chemical what? Equivalent. Equal to their chemical what? Equivalent. So M1 over M2 equal to E1 all over what? E2. So that's that about that. So this is a summary of what we have in theoretical aspect of what? Electrolysis. Now let's go into the past questions under what? Under Jamb. Here are some Jamb questions on electrolysis. And the first question here says that the mass of copper deposited when a current of 2.08 ampere is passed through a solution of a copper salt for 60 minutes is dash. Now, the mass of copper deposited, that's what we have to do for copper. Mass of copper is unknown. Mass of copper is unknown. When a current of I equal to 2.0 ampere is passed through the solution for a 60 minutes. Now, the time is 60 minutes. So 60 minutes multiplied by 60 to take it to seconds. We have what? 3,600 seconds. Now there is a formula that combines the first law and the second law together. It combines the first law and second law together, and that's why I'm going to write it for you, and you need to note it. M is equal to Mr. Q all over what? 96,500 N. Now let me tell you what each term stands for. M is equal to mass of metal liberated or electrolyte used. Mr is the relative atomic mass. Mass of metal, relative atomic mass. Q is equal to quantity of electricity. Quantity of electricity measured in coulomb. Quantity of electricity measured in coulomb. Now The Q can be given as what? Q equal to what? IT. Where you know that your I equal to current in ampere. And T is in time in what? In seconds. Then N is what? Is the number of moles. Is the number of moles or number of what? The number of Faradays. Now, number of Faraday that is able to what? To reduce to reduce the what? The iron used. So that we are going to know what this number of Faraday is all about as we proceed. So therefore, the question can be written as M equal to Mr. Now, because we know that Q is equal to IT, all over 96,500. This is what? Mr. Faraday's what? Constant. 96,500 is Faraday constant. Please know that. So now let's substitute using this formula. I have to calculate mass of copper. Now, how do I know the number of N? Now, the MR has been given to me in the question. So the MR, let me just write here. The MR is what? Is what? 60 what? 64. And how do I know my N now? N. To know your N now, to know the number of N. How do I know it from what? From what? What is copper? Copper has 2 iron on it. So copper has what? Oxidation number of +2. So it will take 2 electrons to what? To reduce it what? Mass of copper liberated, that is solid. So this one can be written as mass of copper liberated. So now we have copper 2 plus 2 electron. That is copper equals +2 electron will give you what? Copper solid. Now the number of electrons required for this copper equals to turn to copper solid is 2 electrons. So really it is 2 Faraday now. So it requires 2 Faraday electrons. So N is equal to 2. So here you have N here, you can write it, N is equal to what? 2 here. So substituting all these parameters inside this formula, you get your what? So mass of copper now equal to Mr. which is 64 multiplied by what? We are using this formula now. Because we have our Q is equal to IT. I is 2. Then T is what? 3,600 all over 96,500 times 2. Your N is 2. So your mass of copper now will be equal to 2.34. Express is 2.348 grams. So I approximate it to 2.33 what? If you approximate it, you are going to get what? 2.38. Now, when you approximate it, you are going to get what? 2.319 grams. So the answer here is what? Option C. So that is that. My 2 questions says, calculate the quantity of electricity in column to liberate 10 grams of copper from a copper compound. Now calculate the quantity of what? The quantity of electricity in column to liberate 10 grams of copper from a copper compound. Now number 2, now calculate the quantity of electricity. We are looking for what? Key. Now to liberate mass of copper which is equal to what? Mass of copper which is equal to 10 grams. So we are given what? The Mr. which is the relative atomic mass to be what? 64 as well. And what? The Faraday constant is equal to 96,500 N. So this Faraday constant. So we have what? We have, where is our N? If we want to use this formula now, Mr. This because it's Q that we are looking for. So we can easily use M equal to Mr. Q over what? This. To look for Mr. Q, we need your N. So N is equal to copper is copper. We are dealing with copper as well. To be Cu2 plus 2 electrons to give you what? To give you copper solid. This is copper aqueous. So now to get copper solid liberated, we use 2 electrons. So this is N equal to 2. So Mr. Q now, N copper equal to what? Mr. Q all over 96,500 N. So if you make Q solid formula, we have Q equal to what? Mass of copper multiplied by 96,500 multiplied by what? N all over MR. When you substitute it, what do you have? Mass of copper is equal to mass of copper is equal to what? Mass of copper is equal to. Now what's your you are looking for, sorry, we are looking for Q. So Q is equal to mass of copper is 10. Unit for conversion of copper of unit here, apart from the time given to us. So now N equal to what? What is your N? N is what? 2 all over 64. When you do that, you are going to have what? You are going to have which of the options? You are going to have B options. That is 30,156 point what? 3 column. Don't forget that it's column C. So column. So that is it. That's that about that. Now it says that how many Faraday of electricity is required to produce 0.025 mole of copper. Now, how many Faraday? Number of Faraday. They are also calculating number of volts of Faraday. So we don't know it. Number of Faradays or no. So now it's required to produce what? How many number of Faradays of electricity is required to produce what? 0.25 mole of copper. Now, no copper itself is Cu2 plus 2 electrons for it to become what? Copper solid. You must add what? 2 electrons to it. So copper aqueous turning to solid requires 2 electrons. So it requires 2 quantities of Faraday. So now it requires 2 quantities. So 1 mole of what? 1 mole of copper required what? 2 Faraday. What about 0.25 mole of copper we now require now 0.25 times 2 Faraday. This is molar. Don't forget 0.025 mole times 2 Faraday all over what? 1 mole of copper. Now what do we now get now? This multiplied by this mole will definitely cancel this mole. 0.25 times 2, you are going to have 0.5 Faraday of copper. You got 0.5 Faraday of copper with that. That's option what? D. Option D. That's final answer for that one. Now, number what? Number 4. You have to calculate the volume in centimeter cube of oxygen evolved at STP. When a current of 5 ampere is passed through acidified water for 93 watts, 193 seconds. So the time is 193 watts. The time that we use to pass the current is what? 193 watts, 3 watts seconds. And the day because I is what? 5 ampere. Remember that we are just given what? Oxygen at STP. So we know that 1 mole of oxygen at STP, it contains what? It contains 1 mole of oxygen at STP. 1 mole of oxygen and STP now is equivalent to 22.4 dm cube. And if they are asking us centimeter cube, you have to take it to what? To centimeter cube, to centimeter cube. So 1000 centimeter cube. 1000 centimeter cube is equal to 1 dm cube. So this one now become what? You just multiply this one by 1000. So multiply by 1000 now, it will give you what? 22,400 centimeter what? Cube. Now, if 1 mole of this contains this now it means that if 1 mole of oxygen is equal to 24,400 centimeter cube. Now, also 96,500, because 1 mole is equivalent to 1 mole of oxygen equivalent to 22,400 centimeter cube. It's also equivalent to what? 96,500 what? Faraday coulomb. Please know that 1 mole of oxygen is equivalent to 22,400 centimeter cube equal to 96,500 coulomb. Now, what about what? You can easily get our own coulomb also here. And how do you get their coulomb and also define it to mole? How do I do that now? So now let's do it now. So Mr. from Mr. equal to what? M equal to what? Mr. Q all over what? 96,500. Have we? So now you can easily just say that you can easily get our what? You can easily get, since we are dealing with N is 1. 1 molecule of oxygen, N is 1. Just know that. So don't need to carry that. So if you make this one now, we have what? M over Mr. It will give you mass over molar mass. Mass over what? This mass. This is what? Molar mass. Equal to Q all over. Now since this one is 1, to Q all over 96,500. So now just know that N equal to 1 here. So now, so what's your I? What's your Q? Q equal to IT. Q equals to IT. So it means that if Q is equal to I, this is Q. IT over 96,500, which is equal to what? 193. 5 times 193 all about 96,500. Everything will give you 0.01 mole. Or 0.01 mole. So I will come here to finish it up here. So it means that if 1 mole of oxygen is equivalent to what? 22,000 centimeter what? Cube. Now what about 0.01? 0.01 mole now. 0.01 mole of oxygen will be equal to 0.001 times 22,400 centimeter cube. So when you multiply it, you just take it 1, 2. So we have the answer here was 24.00 centimeter cube. So that's option what? Option A. Option A. So that's that about that. Now let's go to question number. What number of copper will be what? Liberated Okay, what number of moles of copper will be deposited by 360 coulombs of electricity? What numbers of moles of copper will be what? Will be deposited by 360 coulombs of electricity? Now, how do you go about that? Just know that M is equal to Mr. Q all over 96,500 N. It didn't give us what mass. We have to calculate what. So M over molar mass. Look at this. This is mass, and this is molar mass. It has given us mole like this. This one has given us what mole. So it's equal to Q all over 96,500 N. So this one is same thing as mole. This is same thing as mole. So equal to now, what's your Q? Your Q has been given as 3,660. Now over 96,500, 9,600 times 2 was 1.865 times 10 raised to the power minus 3. So it's got 1.87 times 10 raised to the power minus 3. So that's the final answer. Option mole. Please put mole. That's mole. Now, given that the mass of a substance deposited doing what? Doing electrolysis, and given that M is the mass of a substance deposited doing electrolysis, and Q is the quantity of electricity consumed, then Faraday law can be written as what? Given that this M, this given that this M is quantity of electricity used, then Faraday law can be written as what? Is this is the first law. M equal to, I told you M is directly proportional to what? Q. Introducing the constant now. E equal to what? Electrochemical what? Equivalent. So this is Faraday first law of for electricity. First law, Faraday first law of what? Faraday first law of electrolysis. Lastly, what quantity of aluminium is deposited when a current of 10 ampere is passed through a solution of aluminium salt for 1,930 watts seconds? So we have I equal to 10 ampere, T equal to seconds, then aluminium L3 plus 3 electrons. Now, aluminium will take what 3 electrons to come solid. So we have N equal to what? 3. So what quantity of electricity is produced? So from this formula, just make what? M equal to what? Mr. Q all over 96,500 N. So multiplied by IT. Look at this. Where Q, Mr. IT all over 96,500 N. So we have the current here is 10, and the time here is 9,030 all over what? 96,500 times what? 3. So I calculate that one. This is 3 here 1, 3 here 7. So 0 cancel 0 here. So 193 here 1, 190. And 6 here we have what? Okay. So when you multiply it, what do you get here? You can press it. What do you get?